Hey everyone, good to be talking to you again after the morning session. I hope you got a chance to um, attend the session in the morning where we talked about the data reliability problem and made the case that data is nothing if not reliable. And purposely I left it talking about the problem, but not digging too much into solution because I have Vivek and Margie now to get into the actual solution and take you through the journey that we went through solving this problem, working with large enterprise customers, right? So what I want in this session is to give you a window into our thought process, represented through Vivek and Margie, who will give you a window into the thought process of our customers in turn and talk about how we have been solving the data quality problem at scale for Fortune 500 customers. Um, just take a minute here to let Vivek and Margie introduce themselves, and then we would make this a conversation where I'll ask them questions. Of course, I'm part of the company, so I understand where we are coming from, but I just wanted it to be represented by Vivek and Margie, and then I'll maybe add some of my thoughts as I go along. Vivek.
Hey, I'm very excited to be speaking to you guys. My name is Vivek. I am one of the co-founders of Lightup. My official title says VP of Product, but I work with my customers end to end, all the way from them starting a POC till they go into production. So a topic near and dear to my heart, and I'll make sure that I give you guys a lot of context on exactly what does it mean to solve data quality at this scale.
Margie.
Thanks, Vivek. Hi, I'm Margie Roginski, and I'm head of product at Lightup. And my background prior to Lightup was in analytics. So I was director of product at ThoughtSpot. And prior to that, I was at Tableau for 4 years. So tons of experience in data and analytics, and super excited to be now working in the data quality area.
And it's my pleasure too, working with both of you, solving the hard, gnarliest data quality problems, right? So maybe let's start there, right? What does it mean to solve the data quality problem and especially solve it at scale? What does data quality mean and what does scale mean in this context?
Sure. I can go first. So data quality, right? So I mean, I think all of us like to talk about it this way now, but generally anything that is not an infrastructure problem. So think of good pipes carrying bad data. So that is our problem, right? So if data is not arriving on time, not arriving in the right volume, if to start there, right? Data should be available and should be fresh. But then you go deeper, right? Does it meet the requirements that the business and business stakeholders have for this data? Are there too many nulls? Is the data conforming to certain requirements? All of those are data quality problems. And that's why it becomes hard, right? There's a lot of different stakeholders thinking about data quality in very different ways. But all of those checks have to pass before you can call data good. And so that's what data quality is for me. And I'll talk about scale maybe after Margie talks about her perspective on data quality.
I mean, what I was going to chime in with there, it actually relates to scale, because frequently companies will do a lot of data quality work with their engineers, actually maybe writing custom SQL in-house, but it doesn't scale. And really, they're working on a few columns or a few tables, but really behind that, there might be literally 50,000 tables. They have so many tables and almost all of them aren't being checked. So when I think about data quality at scale, I think about a way to do those checks that Vivek is referring to, but a way to also operationalize it so you don't have to be focusing on every check, on every column, on every table.
And so that's interesting, Margie. I mean, we naturally think of scale as a problem of number of rows of data, right? Maybe we'll think in terms of number of tables, the number of columns, but what you're getting at is something beyond that, right? I mean, are we talking number of users, number of people involved in maintaining data quality? Like, I mean, what's the kind of people dimension here that you're kind of alluding to?
I mean, that's interesting because that really gets into the personas that are interested in data quality. And really, those are personas all over the company. I mean, it's not just the data analyst that's interested in, or the data quality analyst that's interested in data quality. It's the business analyst that knows what the business needs and is trying to make the decisions and is concerned that the underlying data isn't right. And it's the data engineers that are trying to identify why the data isn't right and fix the problems. And then maybe validate that the problems have been fixed. So finding a way to, I think, create sort of an ecosystem of data quality that can be essentially socialized throughout your company, from the data engineer literally up to the executive. I mean, the executives want to know the data quality trends. How can I just come up with a score for my data quality? So finding an ecosystem for your company where you can really socialize that among all those different personas, I think is very important in adoption and just in general in building confidence in your data.
Right, right. And I'll come back to that question. I think there's another angle that we should dig into personas from. So maybe hold that thought, we'll come back to it. And so Vivek, kind of going back to you, right? I mean, we started this company 3 years ago together, right? And you still remember some of those ideation sessions where we would get a cup of coffee and a whiteboard and that's it, right? And I think your dog too, right? And the three of us would sit there and just like think about what data quality means, and why people need this to be solved. And we speculated about what the solution looks like today in the industry. Looking back at where we started and what we have learned on the field in the last few years, what stands out to you? I mean, or like, what's your read on where data quality is today? Is it a solved problem? Is it something people care about? They don't care about? They have a clean way of solving? Like, when we summarize the space today, what does it feel like to you?
So, I mean, I'll go along three main vectors. Summary wise, data quality is very important. Everybody has bought into it as a concept. So you will see this across organizations that you cannot go to anybody and say, hey, do you have a solution for data quality? And they say no. They'll never say no. It's always that either we have an in-house system or we have a last gen tool that we're using. But the interesting question to ask is, okay, what is your coverage looking like? Are you at a stage where you would call you have solved data quality to a level that you would like? And almost always they talk about coverage being very, very low. And I mean, that's something that was extremely surprising to me. I thought if you would have asked me to guess, I mean, in between you and I too, right? We thought there'd be newer problems that we'd solve, but for some basic problems, the coverage would look like easily 50-60%, if not more. And everybody that we've talked to, right, is in the 5% range, 10% at best, right? And that's just because the data usage has exploded, the number of tables have exploded, data use cases have exploded, right? And it's just very hard. All teams everywhere are playing catch up, right? So that's the one thing that I see almost everywhere, right? The second thing that I see is when you ask why, right? The same answer, right? If you ask me in the past, right? Okay, if you have a small set of checks and you want to just write those checks, run them daily, and put them into production, how long would it take? You or I would have guessed maybe a couple of weeks, but right now, really, the state of the art is, even with the tools in place, in-house or vendor, right? The number that we are getting repeatedly is 6 to 8 weeks. And that's huge,
That's
right?
just to write one check end to end and put it in production.
One check, one set of checks on a small set of data assets, right? And that's what is holding everything back, right? How do you ever, I mean, you started with the question on scale, right? We're talking thousands of tables, hundreds of columns per table. In some cases, you want to do fine grained analysis. I want to look at null values by store, right? Or data coming in by store. I mean, think of those millions of checks that you want to run. And if you're going at this speed, of course, you would never have the coverage that you want, right? So that's the second thing is that I saw, was that the overall process is very slow. There is people aspect to it. There is the whole process aspect to it, and we can dig into that in the next set of questions. But that was the second thing that stood out, right? And then the third thing was, I always thought that, there will be a set of users that would be happy with the current status quo. And what I'm seeing is, for all of these personas that Margie mentioned, and we'll dig into those as well, right? Everybody is unhappy. Everybody feels underserved. And that was surprising to me, which means there's like a huge opportunity here. Problem is well recognized, well understood, in the sense that here is what I want to be solving, but how is unclear, and there's so much scope. And that's what gets me excited about solving data quality today.
So maybe talk a little bit more about that, right? When you say like everyone's unhappy, I mean, there's kind of two different things we're talking about. Coverage being low. So maybe help me understand a little bit more what you mean by coverage. How are you even measuring coverage, right? And when we say coverage is low, what exactly is the metric here? And then when we say everyone's unhappy, right, even in places where you would suspect data quality is well taken care of, is that because the coverage is low, or there's some other issue even when the organization has actually been able to accomplish good coverage?
So I'll talk about it, right? So coverage. So first of all, let's define coverage, right? Let's say there is a basic set of checks that you almost always have to do before you use any data.
Mhm.
That's the bare minimum requirements. Things like, is the data coming in right volume? Is the data fresh, right? Are the columns that I'm using do they have too many nulls, right? Did the schema suddenly change on me? Even those basic checks, if you want to cover across all the tables and columns of interest, and I'm not going any deeper than that, even at that level, for the tables that are being used for critical data product, we see less than 5% of them are covered. So that's what I mean when I mean very basic coverage, right? And of course, the end state that people have in mind is you have this basic coverage and then you build on top of it, right? More people come in, they have more business requirements from data that they then abstract into checks that would eventually be put into production, right? But I'm not even going there. That's what I mean by coverage, just basic set of checks that should be run for any data asset that you use.
Kind of like number of tables that you're trying to monitor times the set of checks you need to run on each table, right? That's your denominator. Okay.
Yes. And the second question was around why are people unhappy, right? Because, I mean, this is a collaborative process, right? So the even after suppose so I'll look at two states, right? One where you are ramping up, so that's where everyone is. The problem is that everyone is in the state of catch up, right? So they write some rules, generate incidents, but then they don't have coverage. So a bunch of other uh, high high use data assets now have some incidents where they didn't even know about it. They discover it too late. So they're always under the pressure to actually triage and fix those issues. Now they're not even able to actively monitor them. So they actually spend so much time just catching up to those issues, fixing them, and then new issues show up, right? So they're always behind in the data quality journey. That's one part of it. The other part is that there is this whole setup around what happens after you have detected that there is a data quality issue. That entire part, which leads to you solving the actual problem, that is terribly underserved. So even after you find some issues, say you have good coverage, right? You find some issues. Then what do you do after that, right? At scale, you would be generating hundreds of such incidents, right? If there are problems that happen, right? What do you do then? How do you deal with these issues? How do you fix it? How do you validate these have been fixed? None of these have a solution. So what ends up happening is somebody gets this mandate to solve data quality. And all the way from creating and configuring these checks to actually taking care and remediating the issues, they're running into so much friction that their life is hell right now. So they have the mandate, but not the ways to solve.
So kind of talking also about the end-to-end workflow, and maybe visibility is arguably somewhat easy to get, but building a workflow around it and having the support from the tools, so you can detect issue, you can carry it forward as people are working on it, triaging it, and then finally put a fix in place, right? That whole workflow, that's what you think is severely underserved right now.
Yes.
You know, and I come actually from a development background. And so, I mean, I can speak to that because it seems so easy. You know, you can imagine if you're in management and you say, we'll just run these checks, you know, to make sure that our null percentage is below 3%. How hard can that be? Just a little bit of SQL. But the reality is the infrastructure is huge. Like, when do you run the check? Do you run it on all the data? Do you do a pull of all of your data? Do you do it once a week, once a day? How do you know what you've done it on? What if the machine went down yesterday and it didn't happen? You know, how do you make sure that that run reoccurs? How do you track the results? How do you send out the results? You know, how do you know when a problem is fixed? And, you know, all of this is software, and, you know, it's a huge effort for one or two engineers. You know, they often start out saying, yes, I can do this, and they're all invigorated. And then in the end, they really have kind of a maintenance code nightmare. And then maybe the engineer leaves and other people have to take it over. And, you know, we all know where that goes. It's not trivial.
Yeah, I mean, that I find that super interesting, because I was going to ask you next, right? Like, why cannot this just be treated as a BI problem? I mean, it's after all
Right.
running some SQL queries to compute some data quality metrics. We know how to compute KPIs. I was talking earlier today about DQIs, data quality indicators, isn't just like writing a few SQLs, which you could do in Looker or Tableau and then call it a day, right? But you're kind of answering my question here too, right? Which is, it's not just about visibility, but there's actually state to manage.
Right. Yeah. I mean, I had some really interesting interactions with many customers when I was at ThoughtSpot, because ThoughtSpot is a tool for essentially doing search on your data. It's sort of like a high-level SQL interface for people that don't know SQL. And I saw so many customers that spent just hours and hours doing manual searches. They want to know at Neiman Marcus, if a customer gets their hair done, where are they likely to shop afterwards? Or at a major drugstore or pharmacy, how do we characterize the shrink? What are the goods that are being stolen most so that we can put them behind those glass cabinets that are locked up? And they spent a lot of time doing sort of on the spot analysis of these, but it's a one-time analysis and you don't understand the trends. And in the end, you get a result, but the reality is you actually don't know if the result is right. And there were plenty of times they would do this and then they would later find that the data had been corrupted in some way. The results didn't make sense. It had to be redone. And it was just very, very manual. And I think that sort of using data quality trends and looking at the overall data, using an ML learning analysis engine, using some intelligence can really bring out more than a single smart data analyst can do with a tool like that.
That's where it really starts to become a problem of scale.
Right. Yeah, exactly. Right. Yeah.
Teams here.
Right.
Yeah.
And a lot of these issues just you might find something about your shrink, but it's not meaningful unless you know what the trend has been for the past 3 years.
Yeah. So, one interesting question I always like to ask any founder in any startup is, what did you think the problem is going to be when you started the company, and what do you think it is now that you have been doing this the hard way on the field for 3 years, right? So Vivek, where do you stand on that?
I will ask you the same question after this, though. I'll turn the tables on you and ask you the exact same question. For me, I thought it's a problem of scale. If you do good anomaly detection to come up with bounds on these checks, then that solves majority of the problem. What I learned was data looks like modeling can look very, very different. So making it very easy for somebody to express what is it that they're trying to measure as a metric is the big barrier to entry. And if you don't simplify that to the point where it's stupid easy, not stupid easy, but easy, where you can just do a drag and drop and just go from there instead of somebody having to come in and think of a logic. If it can be written in an Excel sheet, if you make it that easy, that's when you can solve it at scale. Because eventually the number of checks that you're trying to put into production, they cannot come from one person. They have to come from a team. It has to become self-serve. It has to be democratized. And that's when somebody would solve the problem. And the number one barrier to that is not the bounds. The number one barrier to that is actually getting to the metric definition. So think of when column A is of type ABC, column B should be XYZ. I shouldn't have to do anything more than this to actually come up with this check. If the rest of the instrumentation is taken care of me, I would feel welcome to come and enter this check in the platform. Anything more, and I would pass this to a development team. That was huge learning for me. And that's like change the mission that at least I've been on. Now I think of anything that anyone ever has to do manually and make it automated. Was there a second part here?
Across all the transformations in your data, like I think we've seen that also when working in our customers. It's not just looking at your data and making these, these automated decisions or finding the automated trends. It's looking at the transformation in the data as it goes through the pipeline, which might be, who knows what, 8, 10 steps, who knows more, and seeing like, is the data at each step consistent, right? And doing that in an automated way.
Exactly. And so yeah, that whole that was a mindset shift for me, at least when I went to the field, and I was like, okay, that's where you're stuck.
Yeah.
Then come the bounds, then come the checks. But I'll
Yeah,
turn the tables on you. You tell me.
I have a very similar read too, and not surprisingly, you've gone through the same experience. But like what I thought the hard problem here was um, kind of the AI ML piece of it, right? The magic part where you can interpret what's good data and what's bad data. Turns out humans are actually really good at specifying good versus bad, right? The hard part is actually being able to do that with minimal amount of effort. And where, what I've also been seeing is that the big bottleneck actually is, when you think of scale and we talk about data quality at scale, we've been doing that today, right? It's not about the row count as much as number of tables and number of columns you need to monitor or number of cuts of data you need to monitor. And then the unit cost setting up just one data quality check, right? That starts to accumulate. Like if you just wanted, you're a small data shop, you're trying to do this for a few tables, you don't need something like Lightup, right? That's a reasonably easy problem to solve. But at the enterprise scale, you can solve this problem for 1 to 5% of tables. And then we are seeing a lot of failed initiatives where the project just stops, right? And years fly by. Teams of 5, 10, 15 are not able to solve the problem in 2 or 3 years. And it becomes a configuration problem, or it becomes this implementation problem where things get stuck, right? Be it writing too much code because that's how their own data quality system was designed, or writing a lot of SQL if that's the language of choice, or just trying to run an analytical exercise every time there's a data quality check to run. And none of those approaches actually scale. And the bottleneck is just being able to set up data quality checks because your data landscape is constantly evolving. You're adding new tables, new models, you're changing the schemas. Data definition itself is changing. What used to be good data yesterday is no longer considered good data anymore because maybe macroscopic environment has changed. And so like being able to keep up with changing shape and form of data, that's where things get stuck all the time. And like you could pick up Datadog, which lets you monitor CPU metrics, but also lets you define custom metrics. It doesn't work because defining your own data quality metrics is too slow a process. And the same problem hits you when you try to do this with something like Looker or Tableau. You're just down to writing SQL queries for every single data quality check. Also doesn't scale. Or you try and write your own, Python jobs for testing data, works, but doesn't scale, right? And the hard part for us, and kind of the biggest value proposition, has been to find this balance where there's enough flexibility that you can measure data quality in your own way, yet be able to set up a data quality check in minutes without writing any code, right? And finding that combination, I think that's been the hardest but the most exciting creative process for us.
Yep.
Cool. So I think there's some very good insights that we're able to bubble up. Just wanted to talk a little bit about what the process looks like. I know we were kind of talking about setup of data quality being the hard problem to solve and the main crux of designing the product, right? So what does that process look like? I mean, why is it a challenge? What needs to happen for this to become reality?
Take it away, Vivek. You got 2 minutes.
Okay, so now I'll go really fast, right? So I mean, really, it's three things, right? So the first part is prototyping, where somebody is just profiling data to discover what it even looks like, right? Then they're defining their requirements on data quality, then translating them into some sort of rules, which are like DQIs in our language, and bounds, right? And then trying to preview it on past data to see what, or at least like on a small sample data, right? And then from the small sample, you go in the implementation phase where you're actually trying to put this into production. So you might have a notebook worth of data that you were experimenting with, and now you put something into production. So it's like, what does it look like at scale for millions of rows coming in per day, right? And then you test that rule for scalability. You then harden the rule definition, meaning you check what the rule does on production data. There's a lot of back and forth in each of these, right? And then you iterate and implement till there is consensus. And then there is the hard problem, okay, that I alluded to in the beginning, is What do you do then? Okay, you generate a bunch of incidents. How do you raise alerts? How do you effectively collaborate on each of these incidents, right? How do you fix it? How do you revalidate it? And then among all of this, right, if you're bringing AI and ML into picture, then there is this whole feedback loop. If something is not looking good, can you pass feedback to the system to actually improve? So all of those components are involved in actually solving this problem end to end. I kept it really brief because we are short on time, but definitely stop by if or reach out if you have more questions on this, because we have done a lot of thinking and a lot of good work in this area. But you have to think about each of these aspects to actually come up with the solution, right? Each of these problems have to be served in a good enough way for somebody to be able to come up with an organization-wide solution.
Any closing thoughts you would like to add, Margie?
Just that I've been so like the field has so much depth to it. I really feel like this field is in its infancy versus analytics, which has really matured a lot, over at least 10 years now, 10 or 15 years. And that's fun. I feel like we're just at the beginning, and I've seen all the features that we're starting to develop, and Vivek's been driving it by talking to all these different customers, and I think it's fantastic, and we got a long way to go in the field in general and as a company.
Cool. Well, thanks a lot for sharing your insights, Vivek and Margie. We are going to be around after this session. Feel free to come by our booth and talk to us in more detail or ask your specific questions. And hopefully sometime soon we'll get to meet you one-on-one or even in person. Well, thanks a lot. That was Lightup.